Yes, but all of you see, now we will discuss about perpendicular and parallel axis theorem. This both this theorem are applicable for determining the moment of inertia of different geometrical body about the different axis. What is the purpose of this? What is the use of, what is the application of this theorem? This two theorem will be used to determine the moment of inertia of different geometrical figure about the desired axis. Now you see here, what are the two theorems? First one is parallel axis theorem. Parallel axis theorem. Axis theorem. See here, this is any geometrical body. For example, this is a lamina. Lamina means plate. And this is the center of mass. This axis is passing through its center of mass. This axis is passing through its center of mass. So the moment of inertia about this axis is symbolized as IC, moment of inertia of the body about the axis passing through its center of mass. What is the mass of the body? M is the mass of the body. M is mass of the body. Mass of the body. Now, if we want to find the moment of inertia of this same body, this lamina, about this axis, which is passing parallel to the axis which is passing through center of mass. Now, this is the axis about which we want to find the moment of inertia. And this axis is parallel to the axis which is passing through, I say is what? I say is the moment of inertia about the axis which is passing through the center of mass of the body, CM4 center of mass. Now you see here, according to this law, the moment of inertia about the axis which is parallel to the axis which is passing through center of mass will be the sum of moment of inertia about the axis passing through center of mass plus mass of the body and square of perpendicular distance. And what is the distance? What is the distance? D. Square of perpendicular distance. Square of perpendicular distance. This is what parallel axis theorem. Write down. According to this theorem, the moment of inertia about a given axis, which is parallel to the axis passing through center of mass, passing through center of mass will be CM4 center of mass will be the sum of moment of inertia of the body about CM center of mass and product of mass of the body and square of perpendicular distance and square of perpendicular distance of axis. Now, see here, let us try to understand this one. This is the axis which is passing through center of mass, and about this axis, the moment of inertia is known. I see. The moment of inertia of this body about the given axis which is passing through center of mass is known. Now there is a axis which is parallel to this axis. Which axis? The axis which is passing through center of mass. And about this axis, if the moment of inertia is I dash, and we want to find this one. Now, the moment of inertia about this axis will be the sum of moment of inertia about the axis which is passing through center of mass and plus mass of the body and square of the perpendicular distance between the two parallel axes. The square of the perpendicular distance between the two axes. Between the two axes. Now see here. Yes, beta. Now, let us apply this theorem to solve some problems. See here, beta. This is a ring, and this is a what? A ring. For question number 1. What is the mass of the ring? M. What is the radius of the ring? R. Axis is passing diametrically. Now, you have to determine the moment of inertia about the tangential axis. You have to determine the moment of inertia of this ring about the tangential axis. What is the question here? Find out the moment of inertia. Find out the moment of inertia of the ring about tangential axis. About tangential axis. Tangential axis. This is your question. This is your question. Now, how we can find this one? By applying parallel axis theorem. By applying parallel axis theorem. Parallel axis theorem. What is the parallel axis theorem? About the parallel axis. This is the axis which is passing through its diameter. So about this axis, tangential axis, we consider moment of inertia passing through its center of mass plus mass of the body. This is ring. And what is the perpendicular distance? Square of the perpendicular distance. Now you see here, we have already derived this one, that moment of inertia about the axis which is passing through its center and passing along the plane, that is along the diametric axis. This moment of inertia is half mr square. We have already derived this formula, half mr square. Plus, we are applying which theorem? Parallel axis theorem. We are applying parallel axis theorem to solve this problem. So IC plus body ka mass of the body, and what is the perpendicular distance? This is equals to radius. So nothing is there. You can treat 1, 2 plus 1. 3 by 2 mr square. 3 by 2 mr square. So moment of inertia of the ring about the tangential axis will be 3 by 2 mr square. This is 3 by 2 mr square. Now here, see here, question number 2. See here, this is question number 2. If the ring is like this and axis is passing perpendicular to its plane and tangential, tangent, this is tangential axis. What is the radius of the ring? R. What is the mass of the ring? M. Determine the moment of inertia of the ring. Determine the moment of inertia of the ring about the tangential axis. About the tangential axis. About the tangential axis, which is perpendicular to the plane of ring. Plane of ring. To the plane of ring. Now you see here how we will solve such kind of problem. For solving, you already know if the axis is passing through its center and perpendicular to the plane, then this axis is IC, and we have already derived the moment of inertia about the axis path of the ring. What is the moment of inertia of the ring about the axis which is passing through its center and perpendicular to its plane? It is mr square. Now this is the tangential axis, and this is also perpendicular, like this is the circle, this is the ring, and this is the plane. Axis is passing like this. Axis is passing like this. But here is the question, the axis is not passing through its center but along its tangent and plane perpendicular to the plane. Now we will apply according to parallel axis theorem. According to parallel axis theorem. IT. Parallel axis theorem. IC plus what is T for tangential axis of the ring? Mass into distance square. We know moment of inertia of the ring about the axis passing through its center is, and perpendicular its plane is mr square. Plus body ka mass m, and what is the perpendicular distance? This again here r square d square. Mr square plus mr square is 2 mr square. So here in this case, the moment of inertia will be 2 mr square. Will be 2 mr square.